And if we go back to Todd's work, he writes this, which is really important. It is well known that in untrained populations, there is typically a greater proportion of type 2 compared to type 1 muscle fibres. In tetraplegics, remember that's very high on the spinal cord, the composition of the anterior deltoid muscle was 74% type 2 compared to 57% in paraplegics and 42% in able-bodied. And leg muscle was reported to contain more type 2 muscle fibres in the spinal cord injured athlete compared to the able-bodied athlete. So it's kind of suggesting to us that there is a change in fibre typing as a result of the spinal cord lesion injury. Now, can we show this? Is there an evidence base that will help us support this? Well, there is. So this is some data that came out back in 2001, and what they've done is they've tracked a group of individuals post a spinal cord injury. And they've tracked these in two groups of muscles, the soleus and the gastrocnemius. So fundamentally, these are muscles within the lower limb. And so here we've got our months post spinal cord injury. So if we kind of take almost immediately, 1 to 2 months past, look at the fibre type distribution in the soleus. 30% type 1, 24% 2A, 26% 2B. But as we progress over the months, look what happens to the type 1 fibres. Look what happens to the type 2s, particularly the 2As. Okay, so the 2As, they start to decline, but you also see a decline in the type 2Bs. So fundamentally, you're getting a decrease in the total availability of muscle, and actually the greater decline is coming in the slow twitch fibres compared to the faster twitch fibres. If you look in the gastroc, same thing. The type 1 fibres, the biggest decline, far bigger than you're seeing in either the type 2A or the type 2B fibres. and there is, there's a fundamental reason for this, which is fundamentally these fibres are oxygen dependent fibres and require that redistribution of blood flow to those regions. But if we've got a spinal cord lesion injury, we have now lost control in terms of vasodilation and vasoconstriction to those muscles. They don't get perfused as readily. And so that's why we lose things like temperature regulation in those parts of the body, because they don't get the warming effect coming from the blood. And because the muscle fibres are no longer being engaged in those muscles, they are down-regulated. They're all down-regulated because the muscle mass is being used less. But the type 1s are proportionally down-regulated more because fundamentally they are not being perfused with the oxygen because you've lost that ability to vasodilate, vasoconstrict, and get a redistribution of blood flow. Now, if we look at this, this is quite nice data to look at. So here we've got 2 slides which have been taken. These are kind of biopsies that have been taken. And what we're looking at here is capillary networks. And in panel A, you've got a capillary network in a healthy, non-spinal cord injured individual. And in panel B, we've got the capillary network in somebody that's got a spinal cord lesion. And it's not particularly clear to the untrained eye, but fundamentally what has happened is there is a reduction in the size of the network. If you look, the network it's a greater netting on this side than on this side. It looks like there's more, but it's because fundamentally what's happening is, can you see that the size, what's happened is the size of the capillaries has had to increase to compensate for the fact that the surface area has decreased. And that's, again, a function of what we were referring to on the previous panel, which is as you get the spinal cord lesion, because you lose that neural control in terms of redistributing blood flow to those limbs, there is still blood flow, but the body's response is, because blood flow has been reduced, it fundamentally, you lose the capillarization, but any capillaries that aren't being lost are being expanded to compensate. So the net result is you've lost the network, the total size of the network, and the body is trying to compensate by just increasing the size of the remaining capillaries to compensate.